Welcome back from lunch. Decided to wait a few minutes past 1:30 because I figured people would be enjoying the new friends that they've made in the lunchroom. But let's go ahead and get started. So today I'm going to be talking to you guys about the mobile JSON wire protocol, and Simon Stewart was kind enough to give a little preview of what we're going to be talking about today and how it fits into the larger picture of Selenium and what Selenium is about, the future of Selenium. So we'll dive more into depth. This is me. I work at Sauce Labs. I manage an engineering team there. And I'm also the project lead for Appium, which I think you'll have heard a lot about at this conference if you haven't heard about it before. We did a workshop yesterday, which I think was really great. And I'm also involved with this mobile JSON wire protocol thing, which is kind of the evolution of the automation spec with mobile specifically in mind. I also like JavaScript a lot, which proves that I don't really care what Simon Stewart thinks of me, based on his comments earlier today. We talk about that a lot and have not come to any agreement whatsoever. So this is what we're going to look at together. I'm going to start by talking about the JSON wire protocol, so not the mobile version, to give you a kind of sense of how Selenium is put together from a protocol point of view. In the process of that, I'll talk a little bit about HTTP protocols in general. Specifically, some details around the JSON wire protocol, and then what extensions we've added to the protocol to this thing that we're now calling the mobile JSON wire protocol. Finally, I'll talk briefly about how the Webdriver spec fits in with the JSON wire protocol, mobile JSON wire protocol, because we are in a period of transition, and so some things are not as clearly defined as we might want. So the JSON wire protocol, the one that's been around for a long time now, is essentially, I've defined it here as the abstract specification of how automation behaviors, things like clicking or typing or whatever you actually want to do with your automation, are mapped to Selenium or Appium or whatever HTTP requests and responses. But first of all, let's talk a little bit about what the motivations were for creating the JSON wire protocol to begin with. What's the motivation behind it? Because we could have gone a different direction. So here's a couple of my thoughts about it. And I'm saying we here, not because I was involved with the creation of the JSON wire protocol, but kind of this imaginary, kind of using my imagination to go back to when this protocol was under construction, the decisions that were being made. These are some reasons that it was done this way. So first of all, we felt that it was important to have a client-server implementation. And so if you're not familiar with that term, it basically means that we have something that's split into two parts, where you have a server which handles the actual things that you want to make happen, and a client which sends commands and receives responses from the server, but in kind of this disjointed way. Of course, this isn't the only way to architect a piece of software. We could have done something different, or Simon Stewart could have done something different with Webdriver. So why would you want a client-server implementation as opposed to, say, just a Java program that knows how to do the automation and you just import and include the package like any other program? Well, it was important to think about writing tests not just in one language, but in any language. To be able to use whatever you're familiar with to write tests. So this is one big motivation for using a client-server implementation. Another motivation is the possibility of kind of distributed, of using the system in a distributed way and using it in a more scalable way. So things like Selenium Grid, Sauce Labs, or other kind of Selenium at scale vendors are built on the fact that a Selenium server or an Appium server can be somewhere else on the internet than your test script. And this is one of the beautiful things about this client-server implementation, is that you don't have to have the automation take place in the same context, the same machine, or whatever as the test code. So you can have your tests running on your machine and have a server or a grid hub or something else running elsewhere on the internet or elsewhere on your intranet. It also opens up the possibility of having multiple implementations of a server. When it's not just one piece of software, but is this client-server architecture, you could have multiple different servers that implement the same protocol and could be used equally well by the clients. This is kind of what's happened with Selenium, where we now have things like Chrome driver and IE driver, and now Edge driver and Firefox driver and so on. These can be maintained by different groups of people, and they're all implementations of fundamentally the same kind of thing. But it means that people could write, competing versions of Selenium, or distribute the responsibility of maintaining drivers for different things that you want to automate. So this is seen as a good thing. Of course, one of the things that having a client-server implementation means, you might think it's a good thing or a bad thing, but it's just the way that it works, is that you have to have a standard for how the client will communicate with the server. So that has to be defined in advance, otherwise the client will be sending random things to the server and the server won't know what to do with it. So it was decided that this would be based on HTTP, which was, I think, a good choice because it's the kind of standard layer for pretty much all internet communication. So it was a good base for the specification. Also, going back to this idea of wanting to be able to write tests in any language, every language worth writing tests in basically has an HTTP library already. So it's easy to implement the client side of this equation in pretty much any language. This is also true for the server. Most programming languages have facility, have libraries, whatever, for creating HTTP servers. Java, JavaScript, Python, all of these have really convenient ways of very quickly spinning up an HTTP server, setting handlers for various routes, and so on. So it's a really good choice for this, as opposed to coming up with some other mode of communication. Another motivation is that anybody can implement an open protocol. So this goes back to what Simon was saying earlier this morning, that for him the goal of Selenium WebDriver was always for it to go away, for the responsibility of exposing the automation behaviors to fall on the vendors themselves, not this tool called Selenium. And the way that that happens is by creating an open protocol that everyone, all these different browser vendors, can agree on so that they can implement it individually. And this is what I was just saying earlier. This is what makes it possible for these various browsers to all be stitched together seamlessly into this one tool, Selenium. And Simon's vision is, in the process of becoming realized now that, the Chrome driver project exists, and since, Microsoft has just done the work for Edge driver and so on. But these can all be used equally well by the client, or, with very little effort stitched into one kind of one server like Selenium or something like that that can provide access to all of these other drivers. Okay, so I've been talking about the fact that the JSON wire protocol is an HTTP protocol, and in case some of you haven't worked with them in your own programming history, I thought I'd go into a brief introduction of how they work. So this is a pretty simple diagram. You've got an HTTP client and a server, and they go through this kind of process of communication. The idea is that you use a client to make something happen or to get some kind of information on or from the server. The server is the thing that actually will do the action that you want to have done. And then it will reply to the client with some information about what happened, whether it happened successfully, and so on. And so there are a couple pieces of information that every kind of bit of this conversation must include. From the client side, it sends 3 things to the server every time it wants something from the server. So first of all, HTTP has this concept of verbs, where there's a small number of kind of basic things that you can do or you can tell the server to do. This is like get and post and other things you might have heard of. There's also the concept of a route for a request, which is a specific address for a resource that you're looking for from the server. So if you think about any website, you have your domain, google.com, for example, / and then a series of strings separated by slashes. That's the route portion of any URL. And that's part of the request. The other important part of the request is a body, which can just be any kind of string you can imagine. So this is all sent over to the HTTP server, which, based on the verb, the route, and the body, decides what to do as a result of your request. It can then go off and get information, maybe from a database. In the case of Selenium or Appium, they will go off and perform some kind of automation behavior with your app or your browser. And then the server, since it just did this action, knows whether it happened successfully, whether it was trying to get any information at the same time, and it wraps that up and sends it back to the client over HTTP. And it does this with 2 bits of information, the status code, which is an HTTP level thing, and then again a body, which can be an arbitrary text basically, that the client can then use to interpret what happened on the server. So here's some more details about what's included in each of these. This is kind of what I just spoke through. So an HTTP verb is the general kind of thing you want to do. The verbs include get and post. Get is when you're trying to retrieve information from a server. Post is when you're trying to make something happen on the server, and so on. Let me make sure to go through this in enough detail. So the only thing that I didn't really mention was specifically was the HTTP status codes in the response. So specific numbers are attached to specific kinds of things that the server is telling you happened. So 200, for example, means that your request was completed successfully. 404 you're familiar with from using websites. When something doesn't exist on the web, this is the error code that you get. 500 means that something bad happened on the server, and so on. Okay, so let's take this concept of an HTTP protocol and apply it to the JSON wire protocol and see how it defines itself in terms of HTTP. So first of all, if you want to know more about the protocol, this is the URL for it. There might be a new one now that Selenium has moved off of Google Code, but this is the one that I always go to. So there it is. So what HTTP verbs are used in the JSON wire protocol? There are 3 that are used: get, post, and delete. Get, as I mentioned before, is used to retrieve information from the server. Some examples of how you would do this with Selenium: you could get the status of the Selenium server. You could get the text of an element, for example. These are both used with the get verb. If you want to make something happen or maybe retrieve some info, but potentially in a way that has some side effects, you use the post verb. And for some ways that you do this with Selenium are, for example, when you start a session, that's done using post. When you find an element, that's done using post. And when you click an element, that's also done using post. There's only one action that is triggered using the delete verb, and that's when you end a session, because you're essentially deleting that resource of a session that you're currently automating. What routes are there in the JSON wire protocol? Well, there's a lot of them. I didn't go through and count, but it feels like there's hundreds of them. There might be less than 100, but it's a lot. What's interesting is that the actual structure of the automation behaviors, which is object-oriented, are encoded into these routes. And that's just kind of a way that it's designed nicely and sensibly, so you can kind of read the structure of the API off of the routes that are in the protocol. So some examples, you have the /status route, which if you combine it with the get verb will give you the status information for the server. We talked about starting a session. That happens at the /session endpoint. And if you connect to that using the post verb, you will create a session, assuming that you send in the right body as well. Or you could get a list of the sessions that the server is currently running using the get verb and then the /sessions route. So then what response status codes does the JSON wire protocol say that the Selenium server or the Appium server should respond with? Well, generally, if you get a 200 back, that means that things went okay, as expected. If you get a 500 back, that means that something went wrong, and we'll send some more information about what went wrong in the response body itself. If you tried to access a route that doesn't exist, or the route in general exists, but you sent it in with a bad variable or a bad ID for a session or something like that, you'll get a 404. Finally, if you're running a test against a server that maybe doesn't fully implement the JSON wire protocol, it's supposed to return a 501 status if you try and request it to do something that it knows is a valid thing for you to request, but it doesn't actually implement that action, doesn't implement that behavior. So this is useful when you're actually building out a server implementation because you can have these kinds of valid responses to tell the client, hey, look, we're not quite there yet. We haven't built out this behavior. So then the only part we haven't talked about is the request and response bodies. The main thing to realize here is that everything is JSON. That's why it's called the JSON wire protocol. So the body of a request is JSON, and the body of a response is also JSON. And JSON is just text, but every programming language pretty much has a way of turning that text into objects that you can use in the programming language in a more native way. But this is all just structured text, basically. If you look at the JSON wire protocol documentation, you'll see that every route has a description of what kind of JSON object it expects in the request, and then what kind of JSON object it will serialize and send back to you as a string in the response. So let's take a look at an example. If we're creating a new session, which as we just saw was the combination of the post verb and the /session endpoint, we actually have to send in this kind of JSON string called desired capabilities object. And everyone knows from using Selenium what desired capabilities are. This is what they look like as a kind of minimal JSON string. You've got your desired capabilities key, and then for Selenium, for example, a browser name key. So this is just a string that gets sent out as the body of the request. And then the responses, likewise, are always JSON objects that are serialized into strings. They have a bit more structure in them, so you can kind of expect this structure from any successful response. First of all, there's a status, which goes into more detail from the server's perspective about whether your request was successful or whether something bad happened. And it has a value, which serves to provide more information to the client, or in this example, give you an ID of an element that you just looked for. So this is what the response for find element looks like. So a bit more about this concept of a JSON wire protocol status. First of all, why do we even have this? The main reason is that the HTTP response status codes are not really specific enough for all the kinds of things that might happen in a Selenium or Appium automation session. So we want to be more specific, especially when we run into an error, so that the client can give useful information about that error back to the user. So here are some examples. There are actually dozens of status codes that are specific to the JSON wire protocol. But here's just a couple examples. If it's 0, as in this last slide that I showed you, where the status here is 0, that means things were successful. There's no error. And then any non-zero status is some kind of error. For example, 7 is defined as the no such element error, which is what happens when you try and find an element that Selenium or Appium can't find. Or if there's some problem in starting your session, you'll get the error code 33, which means the session could not be created. Something else to know about this API is that there's kind of an inherent difficulty in any HTTP API, which is that HTTP is stateless, which means that in between every request and response, the client and the server are not connected. So from the perspective of the client and the server, each bit of communication happens on its own. So the problem is that typically what we want to do with HTTP APIs is not stateless. So your test needs to keep track of elements from one command to another. You want to find an element on one line of your test code. You want to click on it on another line of your test code, which in each of these is a separate request and response from the client to the server, which means that somehow both the client and the server need to keep track of anything that should, from the point of view of the tester, persist between commands. Some examples of things that we want to keep track of are objects like sessions. Every command that you send needs to be associated with one session or another, and you don't want to be randomly picking sessions on different lines of your test code. Elements, as I just mentioned, and even things like windows, frames, or contexts all need to kind of have this imaginary persistence between commands. And the way that we work this out is that the server actually, whenever it needs to instantiate or work with one of these objects, it assigns it an ID. And then we'll give that ID back to the client so that the client can use them in subsequent requests. For example, we have a route here which is /session /session ID /element. This is, again, kind of what it looks like to find an element. There's a couple things to notice here. One is that there's this weird colon in front of session ID. That signifies, from the point of view of the protocol, that this is actually a variable. You're not actually sending in :session ID. You're sending in whatever the ID the server gave you for the session you're currently automating. This helps the server to now associate your request for finding an element with this particular session that it knows about. Let's say that it finds the element and returns back to you this JSON body that we saw in a previous slide, where the value is this weird JSON object with the key called element, and then this value of 1234. That 1234 is the element ID. Now the client knows what that ID is, and it can use it in any subsequent requests to the server that have to do with that particular element. So let's say we wanted to click the element. Well, you can see the definition for the click route. It's post plus this route here. And you'll see that there's a slot for a new variable, which is element ID. So if we wanted to click on the element we just retrieved, the client would know to replace element ID there with 1234, which is the ID of the particular element we care about. So that's how we handle keeping track of objects between different requests and responses. A couple more words about the clients. So a JSON wire protocol client, which is a Selenium binding or an Appium binding for a particular language, is to provide a language idiomatic interface. In other words, something that a Java developer or a Python developer would be able to use. And it's supposed to kind of hide the details of the protocol. So everything that we're learning about here should be hidden from view when you're writing tests. You should just be writing your tests in Java using an API that's comfortable and familiar to you, but this is what's going on behind the scenes. The fact that we have this client-server architecture also means that the server doesn't really know or care about what client you're using. All it's getting is HTTP requests. It doesn't know that they're from Java or from Python or from this particular one of the 15 JavaScript Selenium clients that exist. It just gets the requests and responses. One of the outcomes of this is that the server can never reverse engineer your test code based on the request that it receives. So this is kind of an illustration. If we had the test code on the left here, which is Python, I might have gotten some of the commands wrong. I just made this up, but the idea is that we create a session, visit a URL. If the title is Google, we quit. Otherwise, maybe we potentially do some other stuff. But from the perspective of the server, what's on the right is just a screenshot of the Sauce Labs command log. The server only knows that we sent, post session or post timeouts implicit wait or post URL. And then we ended the session with delete session. It doesn't know that we had a conditional in our code or anything like that. So this is just kind of an interesting artifact of the client-server architecture that this is built on. So we've only really scratched the surface here. I definitely recommend reading the JSON Wire Protocol documentation to dig more into it. There's a lot more complexity. There's HTTP content type stuff. There's different types of the request and response objects for specific routes, more error handling information, and so on. Right, so that's the JSON Wire Protocol. Let's now talk about the mobile JSON Wire Protocol. And the great thing about the conversation that we just had is that it gives us basically all of the information that we need to know to understand what the mobile JSON Wire Protocol is. It's simply the extension of the JSON Wire Protocol. So this is where the current specification lives. It's probably easiest if you just go to github/seleniumhq/mobile-spec and then find this markdown file there. So it's really just these mobile extensions to the JSON Wire Protocol where we have new routes that define new automation behaviors that are specific to mobile. And we also have a couple new locator strategies. And really that's it. So why do we need this? Well, everyone wants to automate mobile stuff. It's just a fact of life. We need to care about it. And mobile automation as a kind of industry should definitely pay attention to the choices that Selenium Webdriver made, which have kind of made it so successful. Things like the JSON Wire Protocol. There's also no reason to reinvent a protocol. The JSON Wire Protocol already exists. It's great. It just needs a little bit of extension to make it valid for mobile. Another thing is that different projects, say Appium or Selendroid or iOS Driver and whatnot, should really be competing on the reliability of the server, their features, and so on, not the specification that they use. So it's much better for all users everywhere if what's really going on is that Appium is trying to make the best implementation of this protocol and Selendroid is trying to make the best implementation of this protocol, not each going our own way and defining separate protocols, which will make it really hard for users to really choose a tool that works for them. So what's the history behind the mJSON WP, as I'll start calling this? Well, most of the work was done at a meeting 2 years ago, actually. So this has been in the works for a while. A bunch of people were involved. Some names here. Apologies to anybody if I left off your name. Tried to remember everyone who was involved. So yeah, most of the work was done a couple years ago, but we've continued to iterate on the spec since then and add some cool things to it. What's the status? Well, it's currently very much a draft. There's a lot of good ideas, but of course some of them will change as, for example, the gestures spec has changed in the Webdriver spec. Also, some of the ideas here are kind of forward-looking in that they describe automation behaviors which we don't really have the power to enact on devices or apps right now because the underlying automation mechanisms aren't there yet. An example of this is arbitrary 3D spatial rotation or positioning. In terms of implementation, Appium, Selendroid, and iOS Driver have implemented all or some of what you're going to see here today on the server side. And the clients, the official Selenium clients, are getting updated with some of these features as well. You might have already used the context commands with your driver, and these are part of the mobile JSON Wire Protocol spec. So let's talk about some of the details of these new extensions. Well, first of all, we have a new desired capability structure, basically because we need more ways to specify combinations of devices and operating systems and versions, and even the choice of which automation mechanism we use, for example, Appium or Selendroid or whatever. Also, we have apps now, not just browsers, so we can't just choose a browser name. We actually have to allow for arbitrary user apps. So these are some of the new capabilities that you'll find in the spec. Things like device name, platform name, which refers to the OS, platform version, automation name, app, as I just mentioned, and of course, you can still use browser name if what you want to automate is a browser. Here's a couple examples. If I wanted to automate an iPhone 6 with iOS 8.4, this is how I would do it, including a path to my application. If I wanted to automate Safari on that same device, I could use browser name instead of app. So browser name and app are exclusive. You can't use both of them at the same time. Browser name is thus kind of a special instance of app. Here's an example for Android where we make use of the automation name capability. So for example, this could be, this is what some people do with Appium, where Appium gives you access to the Selendroid automation backend. So you can just use automation name to specify that you want this to be run with that particular backend and not Appium's UI Automator based support. We've got a couple locator strategies that existed in the regular JSON wire protocol, but now have slightly different semantics. So class name now refers to the native UI class, not HTML class. ID is the native resource ID, like the Android ID, for example, not an HTML ID. And XPath is the same thing as before, only what it's operating on is not an HTML document, but an XML representation of the native app's UI hierarchy. We've also got some new locator strategies, such as accessibility ID, which lets you get an element by the label that developers have added to make that element more accessible. And then a couple kind of custom locator strategies, which are specific to automation backends like UI Automator or iOS UI Automation. These basically let you write element queries in the language that you might be familiar with if you're proficient in those particular automation technologies. We have a network connection API that allows modifying the network state of the device, things like airplane mode, whether your data is on or off, whether your Wi-Fi is on or off. So we have these new routes, the network underscore connection endpoints here. You can get and post. Get will return to you the current state of the device, and post will enable you to change the network connection state of the device. I mentioned in the previous slide that I'm not really good with computers here. Right, so that get and post network connection either return or expect a network connection value. And so what is a network connection object? Well, it looks like this. You've got a type key, and this is just JSON, remember. You've got a type key and then some integer. And the integer represents any combination, any possible combination of network states, because you might be in airplane mode but Wi-Fi on, for example, so these are not mutually exclusive states. And the integer represents a possible combination of them. The way that it works is kind of represented in this table, where all the possible combinations of data, Wi-Fi, and airplane mode are shown here, and then the corresponding type integer for that set of things. And then you can kind of see where we come up with the type integers. It's really the base 10 version of a binary representation where each connection mode is a place in binary. And so you can kind of see how we build this up. It's not super important to understand how this works, but I thought it's interesting. I think Luke came up with this API. It's pretty cool. We have, just today I went ahead and merged a very, very drafty version of the rotation spec, which is about arbitrary movement of devices in a three-dimensional space, so more than just portrait, landscape, and so on. Of course, as I mentioned, the automation tools that we have from Apple and Google don't yet let us simulate these kinds of movement and position input. But eventually, we hope that they will, and this is the API that we'll be able to use to make that happen. So just like network connection, we have some new endpoints under rotation, and they deal with this device rotation object, which looks like this. Basically, it's an object with 3 keys, X, Y, and Z. And the values of these keys represent the angle that the device is rotated about those axes in 3-dimensional space. So if they're all at 0, then the device is in its kind of default or neutral position, which we've defined in the spec, and so on. It gets a little complex, so I invite you to read more details on the spec draft. And here's some images that I made that I'm unreasonably proud of because I used Google SketchUp to do this, or whoever owns that product now. And it's fun. Another thing, contexts. Unlike our typical browser automation session, apps can have multiple contexts. For example, hybrid apps have both a native and a web context. So we need a couple new endpoints to capture this fact about mobile apps. So you can get a list of the available contexts using the first endpoint here. You can get which context is currently active. For example, if you have code that tries to figure out what to do based on what context you're already automating. And of course, the most useful thing is to change the context that you're in. So if you're in the native context and you want to automate something in a web view, you can use this API in order to get into that web view and automate the web portion just like a regular Selenium session. Some interesting tidbits about contexts. One of the issues we ran into, of course, is that some commands only work in certain contexts, like title doesn't really work in a native app context because native app views don't tend to have titles, whereas web pages always do. So we throw an invalid content exception if you try and use something in the wrong context. Or you might try and navigate or get into a context that doesn't exist. So we have some error handling specified around this. So those are basically all that we've added in order to make mobile automation more accessible. It's pretty cool. It's really not that many things that we had to add to the JSON wire protocol, which shows how much overlap there is between automating a web browser and automating a native app. And as Simon pointed out this morning, really you could think of the protocol as specifying a way to automate some kind of UI hierarchy, not specific to web or native apps. So what's left to do? Well, we want to create a set of mobile apps that have various features and whatnot that we can use to test this spec with, and a set of reference test scripts so that anybody who claims to support the MJSON WP, like Appium, for example, that we could run this kind of independent third-party set of test scripts against to prove that Appium meets the spec. There's this issue of what the kind of equivalent of page source is for the different mobile operating systems. So we need to define some kind of standard set of XML schemas that we expect when we get the page source for, say, an Android app or an iOS app. And there's probably lots of things that will bite us once we get further into implementing some of these. So how does this relate to the Webdriver spec? This is the URL for the Webdriver spec. If you haven't read it, I highly recommend it. It's very interesting. Reads like a Dan Brown novel. Right now there's this kind of parallel evolution happening, right, where the mobile JSON wire protocol is based off the JSON wire protocol, but the Webdriver spec has kind of diverged from the JSON wire protocol and is changing some things around. And Webdriver spec is, of course, the thing that will ultimately supersede the JSON wire protocol, which means that we'll have to merge the MJSON WP back into the Webdriver spec with some changes along the way. So it's just something to look out for. We're in a period of transition. Some of the differences between the Webdriver spec and the JSON wire protocol, some slight differences in routes, in specifications around error handling, request and response expectations of what those JSON request bodies should look like and what the JSON response bodies will look like. So both client and server implementations of the Webdriver spec are kind of in the process of change, and there will hopefully be a very smooth and graceful transition where clients are updated to handle the Webdriver spec along with servers being updated to respond and receive the right kinds of things for the Webdriver spec as well. So the end goal, of course, is, as Simon put it this morning, no more Selenium. And we could extend that to say no more Appium, Selendroid, iOS driver, etc. It would be nice if we just had the protocol to maintain, and then the vendors were responsible for implementing the automation behaviors. This has been very successful with things like rendering web pages, right? Every browser pretty much knows how to render a web page that looks mostly the same as other browsers. This was a very long and painful process, as many of you can remember. And with the W3C work that the Selenium community has been doing, we're close to this for automation. Maybe the actual end date for this is still a ways off, but we're moving in the right direction. And so I say here, let's make the same thing happen for mobile. This is very optimistic. As Simon pointed out this morning, Apple is probably not going to be inclined anytime soon to get on board with this based on what we've seen from them so far. But we can hope, and we can make sure to be vocal about this future. So how can you get involved? You can check out the draft of the MJSON WP, chime in on any issues. There are a couple to-dos in the draft that if you have good ideas about, you could make a pull request. If you come up with things that we should have a specification for in regards to mobile, but we haven't created it yet, let us know. There's also work to be done on the clients and servers to actually implement the various things that are defined in the spec. And there might be some problems conceptually with the spec that we haven't encountered yet. Gotchas around, rotation, like what happens when the values are this or that we probably just haven't thought through. So with all of our brains, we'll probably be able to make this a much more robust specification. So that's basically it. I started a couple minutes late, so if Marcus approves, we can hopefully have a couple minutes of questions. 2 minutes of questions. And if you have a question, please come to the microphone, which is in the middle here, so everyone can hear. No questions. All right. Well, I was extremely clear. Thank you. Oh, I guess there are questions. Yeah, let's take time then. The mic is not on, maybe? Can... Yeah. Yeah, so you're talking about desktop native apps that are essentially hybrid apps written in Electron or something like that. I haven't thought about that. It's a good question. I know that Appium can actually automate native Mac apps, but I'm guessing that since these are really just web pages wrapped in a very thin native layer, there's probably a way to use the remote debugger protocol somehow to kind of attach to those apps and essentially use Selenium to automate them. But that's just kind of a sketch of an idea. One more question, and then I think we'll be done. I think they turned it on, but you might have to pick up the mic and... Yeah. Yeah. So that's good. The question was, for anyone who couldn't hear, this network connection API is part of the MJSON WP, but couldn't it also be relevant for web browsers? Couldn't it be part of, say, Selenium in the future? And I think the idea is that this will eventually become part of the Webdriver spec, and to the extent possible, hopefully the browser vendors, even for desktop browsers, would implement this as well. Some things don't make sense. I don't know, airplane mode doesn't really make sense on a desktop, but yeah, why not? Okay, thank you everybody.